For years, AI has been defined by one thing: training bigger models on more data. Training large language models has traditionally been divided into two ways. First, pre-training, where models learn from massive datasets, often trillions of tokens. And second, post-training, where models are fine-tuned or aligned using techniques like reinforcement learning. And this process is expensive, time-consuming, and requires massive amount of compute infrastructure. But the industry is now shifting. As AI moves from experimental chatbots to real production system, the focus is no longer just on training. It is moving to inference, the moment when a model is actually used to generate results. So basically, inference is fundamentally different. Instead of learning, the model applies what it already knows to new inputs in real time. And unlike training, which happens once, inference happens continuously. Every prompt, every API call, and every AI interaction. Because of this, inference is expected to dominate the total cost of AI system, accounting for up to 80 to 90% of the life cycle. And this shift introduced new scaling concept, taste time compute. Instead of only improving models during training, we now improve result during inference itself by allowing model to spend more compute per query.
This shift introduces a new scaling concept, test time compute. Instead of only improving models during training, we now improve results during inference itself by allowing models to spend more compute per query. This shows up in several ways. Chain of thought reasoning allows models to generate intermediate steps before answering. Retrieval augmented generation brings in real-time data from external sources. Adaptive systems decide whether a query needs a quick response or deeper reasoning. Together, these approaches improve accuracy without needing larger models, but they also increase the importance of fast and efficient inference. To understand this better, we need to look inside how inference actually works. Inference is not a single process, it has two distinct phases. The first is prefab. This is when the model processes the entire input prompt and builds internal context known as the KV cache. It is highly compute intensive, and the key metric is time to first token. Here, the model generates output one token at a time. This phase is limited not by compute but by memory bandwidth. The key metric becomes how quickly each token is produced. These two phases have very different requirements, and optimizing both is critical for performance. In production systems, there is another layer of complexity. Multiple user requests are often processed together using techniques like continuous batching. This improves overall throughput but can impact individual response speed. Balancing system efficiency and user experience becomes a key design decision. This is why infrastructure matters. As inference becomes the dominant workload in AI, systems must be designed specifically for speed, efficiency, and scalability. SambaNova addresses this with its RDU architecture. Unlike traditional systems, it is built to overcome memory bottlenecks by keeping data closer to compute. This enables faster inference, better energy efficiency, and the ability to run multiple models and switch between them instantly. The direction is clear. The future of AI is no longer defined by who can train the largest model. It is defined by who can run inference at scale, faster, more efficiently, and in real time. Ready to experience the next generation of inference? Run the fastest open source models instantly with SambaNova, built for real-time AI, scalable agents, and production-grade performance.